So here we are back again, and we're gonna go now with basic geometry. Remember I mentioned you this, guys, so for this demo we did 30 and a 30 and two 60s, and there's always a 90 in the corner. So I'm gonna show you a basic piece of math, and this is gonna bring the end to your frustrations, I hope. Let's say you want to do a 120 point here, or we want to do like let's do for example, let's do 120 here. That's a popular one. It's the one on the hexes and stuff. I'm a hex man myself, so pop, we're gonna do 120 point here, and we can do something else on the other edge. Let's see what. Let's start with 120. Let's say I want to have 120 here. So here's the deal. What you do. This stops mattering anymore. Whatever this is, as long as you have place and distance to work and cut, and I actually kind of work by rotating this bed here instead of even checking any of these dials. You're just gonna work with this. This is now your bread and butter. This is your 0 and your 180. Simple math. I want to have 120 degrees here. Take 180 minus 120 is going to give you a 60. 60 divided by 2 is your magical number, and it's going to give you 30 left, 30 right. How does this look? 180 minus that, you got the math here. So you basically just have to substitute these numbers. As I said, what you want to have, that number divided into one left, one right. And I'm going to explain this left and right now. So if you wanted to just have a 60-degree cut, you would just stop on the first step, or you would just go like, okay, I can either take the angle that I want and split it in two, or 180, and let's say, okay, I want to have a 60-degree angle. Well, we can just dial in a 60. So here's what's going to happen. If I want to have a 60-degree angle here, so let's do non-symmetrical cuts just to demonstrate how these tools work. And when I say tools, these are tools. Actually, machining and some woodworking and so on, we actually use this for work holding. I used to work with these. I had like a few of them machine made. Some of them you can buy, but you can make this pretty easily here for your purposes. But this can be used for work holding, you can use it for clamping, there's hundreds of different things, but they are extremely useful, especially if they're done not as a shape, but as a body or a prism in some cases. So if you want to do a 60-degree cut, now your orientations start to matter. Let's say that I want to do a 60-degree cut over this face. Well, I will need a 60 degrees. And I can either tilt it left, I can tilt it, of course, right. And you see this piece that's missing, that's your 30 to a full right angle. That's why you have a set. So, and now you just kind of slide them all together. That's a 60-degree cut in one angle. But you notice we used a 30 here, right? This is now what it's like, those points of perspective. That's a 60. You're done. You want to do a 60, you want to join something onto it, 60 and a 60. You can do 120 for a hex or whatever if you're starting to construct one. But what if you want to do a structural detail that has like a point, and a point that's exactly in the middle? And that's why I'm using these guys, because if you're just doing this and sliding along your big rails, if you slip here, you're going to lose the symmetry. You're going to get the angle, but you're not going to get the symmetry. With these guys, you get your symmetry. And remember when I said, okay, we were doing 60-degree angle. Well, it's a 60 here and a 30 here. But if you take a look at that math, what I was telling, 30 left, 30 right. So left and right, and you just go like hop. 120 symmetrical to your shape. I know this looks a little bit awful because I'm also tilted. Let me put it like this for you guys. So That's a 60. You can do a 60, 60 left, 60 right, 120, or 30 left, 30 right. For me, it's easier to do it the other way around. I was trained like this because I was doing some other stuff. But basically, I would take my shape because I'm doing 180-degree axis. And if I'm doing a square or something, it's like, again, 180 degrees of an arc. But I need to take some stuff off. And I know that I need 120 here. So what am I cutting off? 30 degrees left, 30 degrees right. And that's what I'm left with. It's really useful calculation for example, if you want to do asymmetrical shapes or you want to tilt this, you need some other stuff. It's a very nifty calculations, but basically there's two ways of this. Take the angle that you want to have it, divide it by 2, and that's one of your reference angles, or the one that's going to be tilting it off. I like to take the one that I'm tilting off on this end. And that's basically very simple math here. So you got a 60 here, or a 30 here, but it's your work holding option where you can be cutting and playing with this. And as I said, you always have a good reference point, and if you're missing the distance, you're just gonna be turning the rail, lock it back in, and you can start cutting. As long as you see you're starting to come over the line, this is actually very helpful that it's rotating. So this is how you use these guys. For basic cuts, for basic angles, you got 15, 75, 90, or you can have 30, 60, 90. As I said, that was a homework to make them, and a 45. Just basic first slides that you did with this technique where you unlocked it, slid it over, and then you don't have to do this anymore. You can work hold like this. And this also gives you an option for the following step.